Okay, can you hear me?
Yes.
Okay, I'm
Today I'm
going to
going to
present
present
the
the
Lebanon
Lebanon
case
case
in the
in
ET
the EG
network
network
project.
project.
The
The
site is
site
equipped
is
with
equipped with
several
several
equipment,
equipments,
starting by
starting by
the
the
what was
what was
provided by
provided
the
by
ET
the EG
network
network
project,
project.
the TDR soil moisture sensors, and the Cordoba station that had different nodes and the station itself. You see here some kinds of setup in the field regarding where each node is located and the TDR soil moisture sensors, how they were installed for the depths of more than 100, about 100 centimeter of a depth. And we have also our own equipment in the field regarding the FDR soil moisture sensor and weather station of our own self weather station and a lysimeter that we try to make it function throughout the project. Again, in the site, the characteristics of the reference evapotranspiration goes up more than 1,300 millimeter, and the rain average is 550 millimeter, with no rain, of course, as Mediterranean season in the summer. Again, we've had another nodes that came this year and been installed, update nodes of Cordoba station, been installed also in the field to gather as much as we can field data out of such weather station that was introduced through this project as a new intervention in actual evapotranspiration measurement. And you can see that the setup. These are the different seasons that were grown throughout the ET project. From season 1, 2019-20 of winter wheat, and we entered into potato in summer. Then we then entered into another winter in faba beans. Then we've entered into maize summer, and then another season in winter wheat, and then we've entered the last season of soybeans last season. In season 1 results, we can see the quite correlation between self-computed and Cordoba computed reference evapotranspiration. And the actual evapotranspiration was computed in the KC crop coefficient was also correlated between Cordoba and self computed. And the total actual evapotranspiration was 480, about 480 for winter wheat season. Result of season 2, the crop was grown as early season potato, which is we have different season of potato. We tested the early season of potato, and it was during March 2020. That means we have had some rain on that season, and there was quite good correlation between node, the self computed, and the Cordoba introduced new station. And the soil moisture depletion ETA, we have had that as an only equipment by that time measuring the soil moisture depletion as an ETA measurement. And then we entered into the third season of faba beans. Also, we have tested the ET node is quite good correlation. And then the ETA had shown also quite correlation, good correlation between ETA Cordoba and ETA calculated by field measurements. And then The evapotranspiration of fava beans was about 400 millimeter in the season. In season 4, the maize, also the correlation of it all the time is being well correlated. Actual evapotranspiration was around 600 millimeter, and it was computed by soil moisture depletion and ETA Cordoba. Season 5, also we have had quite good correlation between ET node and the reference evapotranspiration was about 400 millimeter, with an ETA about 400 millimeter, and then the water productivity of that season was about 1.3 kilogram per cubic meter. The season 5, that's also in the season 5, the different sensors were functioning with a quite good correlation between different weather stations. Last season, which is soybeans, we have put the different evapotranspiration and the actual evapotranspiration, the potential evapotranspiration and the actual evapotranspiration on the same graph, and we can see that quite good correlation between lysimeter and Cordoba reference evapotranspiration or actual evapotranspiration, and this is the only season that we had the lysimeter functioning, and we could somehow find some correlation between lysimeter and ETA Cordoba, although our lysimeter is not yet well calibrated, so maybe this correlation, which is not very high correlated, it comes to the fact that lysimeter needs more calibration data, as has been done in Jordan. Comparison between seasons, as we said, the wheat in 2019-2020 with no irrigation, 480 ETA, millimeter of rain, 700 throughout the whole season, but of course it was not cultivated from the beginning of the rainy season. The potato summer season had 400 millimeter of actual evapotranspiration with about 65 millimeter of rain, 122 days. Fava beans had zero irrigation with 400 millimeter of actual evapotranspiration, 500 millimeter of rain, with 154 days as a growing season. Maize was 600 millimeter of rain in summer 2021, with 500 millimeter of 114 days of the whole season. And we've had wheat winter season about 400 millimeter of actual evapotranspiration, 500 millimeter of rain. And then the soybean, the last season, with 266 millimeter of actual evapotranspiration and about 40 millimeter of rain of 83 days. As the challenges, we have had to go through several fixing on the Cordoba station, and then we have somehow used foil to cover the sensor, especially the canopy sensor, which is on the left, the canopy temperature sensor, because it's very sensitive to water. And then we have had also to cover the solar panel for just covering it from the water, the calcium, the heavy water that we have throughout irrigation could even dry out and make a film of white film on the solar panels. And also the itself, the node was also covered by film in order to keep it from water. So we have had some hassle to make this station being protected from the environment around. More challenges throughout the seasons. We have had several issues that happened in the world and also especially in Lebanon. Electric current discontinuity problem emerged in the country, political crisis, economic crisis that hindered us from entering the fields. Canopy temperature, other sensors, other challenges that we can speak of. Canopy temperature might even read soil temperature in the early sowing and the early phase of emergence. Assuring cross-ETA measurement device for validation, we needed cross-validation devices that we hadn't at the beginning. We have had soil moisture depletion, and then later on we have lithometer that needs also more calibration. Soil moisture reading through sensors doesn't account for ETA during irrigation events, and soil moisture sensors require specific operational setup due to communication in Lebanon, so we had that problem to go all the time manually checking on the soil moisture sensors instead of having it being as the weather stations being sent to on a website. What we've learned working with ETA measurement equipment is a daily task monitoring, checking on climate data daily, keep Cordoba station functioning all the time and collecting correct data. Irrigation water from sprinkler system could be highly harmful to equipment, especially with our water quality that is heavy water. Crop data and agronomic data would highly needed throughout the evapotranspiration experiments in order to somehow understand how the ETA is functioning. Soil moisture data should be collected effectively by gravimetric and also could be tested occasionally. And remote sensing should go hand in hand with field data in order also to make more understanding of what is happening on the ground. What comes after diversity of equipment is needed for even